Hi everyone, we are off to section 1.3 today. So section 1.3 is entitled Increasing, Decreasing, and Concavity. But before we talk about those three, we are going to talk about average rate of change. So let's make that definition. A lot of what you do here on out in mathematics deals with rates of change. Calculus, first part of calculus, is all about rates of change. The average rate of change of f of x from x equals a to x equals b is, and it's just a formula, f of b minus f of a divided by b minus a. That should look strangely familiar. It's basically a slope. All right, and like I just said, this is extremely important going forward. You will see rates of change in calculus. All right, let's do an example. So this table represents the annual sales in millions of a product. So let's do this table. I have my year, and then I have sales, and the sales are in millions. Okay, so here we go. My year, we're going to start with 1998. And we're going to go on to 1999. We have about 5 years worth of data. So we're going to go up to 2002. And then 1998. $102 million in sales. Then we move up to 138 million, 166, 186, and 198. That's fantastic. It goes up every single year. So find the average rate of change from 1999 to 2001. So here we go. If I look at the sales, it's going to be my function values. So I'm looking at these 2 points right here from 1999 until 2001. Those are going to be the 2 points in question. So I do 186 is the function value in 2001. 138 is the function value in 1999, and then we would do 2001 minus 1999 on the bottom. So it looks like we get 48 over 2. So my average rate of change over those 2 years is $24 million per year. Remember, that amount is in millions. So 48 over 2 is 24, so it's 24 million. All right, so that's how to do an average rate of change if you're given a table. Let's look at average rate of change if you're given a graph. Okay, so if I'm given a graph, let's try to draw it carefully. So I got my y-axis there, my x-axis there. My x-axis is just going to be 1, 2, 3, 4. My y-axis is going to go up by tens. Okay, there's my y-axis. That 20 didn't come out too well. Okay, here we go. So my graph is going to look like this. And then it goes way up here somewhere, and it's going to swoop down to 420. Okay, so there's my graph right there. I want to find, given this graph, find the average rate of change from x equals 1 to x equals 4. So to do that, it would be beneficial to probably draw those ordered pairs. So that ordered pair there is 1, 10. This ordered pair here is 4, 20. So then my average rate of change, simply put, is going to be f of 4 minus f of 1 over 4 minus 1. So f of 4 is 20, f of 1 is 10, then 4 minus 1 is 3, so I get 10/3. It's my average rate of change on that interval. If you think about it as well, average rate of change is going to be the same as the slope of the line connecting those 2 points. Right, so that slope is going to be 10 over 3. I went up 10 and to the right 3. Okay, average rate of change is just the slope of a line joining 2 points. All right, let's do one if you have it graphically. Okay, if I have the formula, So if I have the formula, here's what I would do. So the example, find the average rate of change of f of x equals negative 2x squared plus 7 from x equals negative 1 to x equals 2. Okay, so to do this one, I have to do f of 2 minus f of negative 1 over 2 minus negative 1. So the easiest way to do this, since we're using Desmos, because I don't really feel like calculating f of 2. I can, but I can let my calculator do it. Now, if I go negative 2x squared plus 7, and I want to find out what that equals when x equals 2 and when x equals negative 1. We could do a point of intersection, so x equals 2. So at x equals 2, y is negative 1. Or a better way to do it, instead of using an x, use some different letter like a t, and then Desmos is going to offer to put a slider up for you. Now a slider is very cool because I'm going to add that slider, and now I can switch my values for t, and then I'd figure out what that function value is at that point. So I need to figure out what it is at 2. So at t equals 2, the y value is negative 1. All right, so now I have f of 2 equals negative 1. So then when I go over, I get negative 1 minus, then I'm going to do f of negative 1. So go back to Desmos. You're going to go t equals negative 1, and you get 5 right there. So now f of negative 1 is 5. So negative 1 minus 5, all divided by 2 minus negative 1 is 3. So that's negative 6 over 3, which is negative 2. So we're going to be doing a lot of tricks on Desmos, as you will see going forward. Okay, now let's talk about the other part of this lesson, the increasing, decreasing, and concavity. Increasing, decreasing, concavity. All right. So increasing, decreasing, and concavity. So here I have, I'm just going to draw some graph. So at negative 3, coming up to 4, and then I'm going to come down to about right there, and then I'm going to come down here to 2, negative 2, and I'm swooping up, back up. Okay, so you can read those 2 points off the graph. All right, now what we're going to talk about is increasing, decreasing, and concavity. First of all, the highs and lows on a graph have special names. The high points on a graph are called local maxima. So this point right here is a local maximum. So that means it's not necessarily the highest point on the graph, but in a neighborhood around -3, it's the highest point. Likewise down here in a neighborhood around 2, this point's the lowest point, so we call it a local minimum. Obviously this arrow here indicates that the graph's going to go way below that point, but locally this is the lowest point. Alrighty? Now, we have increasing, decreasing, and constant, but there's no constant portions on the graph. Constant is just going to be a horizontal, but this yellow highlighted portion of the graph here is where the graph increases. All right, so what we're going to say is this graph increases on 2 intervals. It increases on the interval from -infinity to -3 and from 2 to infinity. All right, so these are intervals, and they're intervals with x values. All right, with x values. So from when x equals -infinity to when x equals -3, the graph rises from left to right. From x equals 2 to x equals infinity, the graph rises from left to right, so it increases. In the middle of those two guys, right, in the middle of the local maximum and local minimum, the graph is decreasing. So we say it decreases on the interval from -3 up to 2. These look like ordered pairs, but they're not, okay? You need to decipher which one it is. Is it an ordered pair or is it an interval? The context of this makes this an interval. And when we describe intervals of increasing or decreasing, we always use x values. All right, now we're going to talk about concavity. So we say that any portion of a graph that bends downward like this is concave down. All right, and any portion of a graph that bends upward is concave up. All righty, so concave down bends downward, concave up bends upward. All righty, so if we look at the graph over here, we look at the portion from -infinity up to this point right here, right? That point I just put a dot in. The graph bends down all the way until we get to that point. Then at that point, the graph starts bending up. All right? So we are concave down on the interval. We do intervals just like we did for increasing and decreasing from -infinity to -1. That graph is concave down. It is concave up on the interval from -1 to infinity, because starting at -1, the graph bends upward. Okay? The point where a graph changes concavity. All right, it may have more than one of these points. So I'll say a point where the graph changes concavity is called an inflection point. Or a point of inflection. Okay? In this case, my point of inflection is -1, 1.5. All right, so there'll be some MyOpenMath questions where you have to answer that. Okay, another MyOpenMath question you're going to see on this assignment is the following. And we're going to turn to Desmos to help us do this one. And let me state the example here. I have a function f of x equals 2x cubed minus 27x squared plus 84x plus 8. So we're going to use Desmos to answer these questions. All right, on what intervals is f of x, maybe only one interval, so I'm put the s in parentheses over here. Okay, on what interval or intervals is f of x increasing? Decreasing? Okay, and then it has a couple blanks to fill in. So the min value at what x value, so when it asks you where a min value happens, it's going to be an x value, okay? And the output is going to be the y value, okay? And we got a max value at x equals with output blank. Okay, so now we're going to turn to Desmos and we're actually going to graph this thing. Make sure you're using your pause button if I'm going too fast, right? I also think there may be an option where you could slow the video down. All right, so I'm going to go over to Desmos. I'm going to clear out the business I have in there, and I'm going to enter that function. You can do f of x, you can do y, you know, whatever. I'll just do y because it's a couple less keystrokes. 2x cubed minus 27x squared plus 84x plus 8. There's my graph. Desmos does not have the whole thing on there. Let's see, is there a thing where I can, nope. All right, so what you can do is just zoom out until you see the max and min. So I zoomed out, all right, or you can tweak, right? Like my x-axis is way too wide. If I want to narrow it, I can go over here to the wrench and I could say, hey, my x-axis, instead of going from -132 or whatever, let's go from like -10 to +10. All right, and then that looks a lot better, right? That looks a lot better. So it looks like this graph is increasing from -infinity up to this max point right here. The beautiful thing about Desmos is you could just click this and you got the max point is 284. All right, so then I can go back to, I could go back here and I could say, okay, max happens when x equals 2 and the output is 84. And then I go back to Desmos and I could say, okay, my min value happens at x equals 7 and the output's -41. So I can go back to my paper or my MyOpenMath, x equals 7, output -41. And there's a Desmos app for your phone too. So if you want to use your phone to do Desmos, you know, have at it. All right, so we are increasing from -infinity up to 2 and from 7 to infinity, right? Does that make sense? You see where my arrow is here? I'm increasing all the way up to x equals 2. And then I'm increasing again from x equals 7 all the way to infinity. So I'm going to put those on my paper now. Go back to the paper. So I'm increasing from -infinity to 2. Sometimes mathematicians will put a little u in there. It means the union of two sets. So union 7 to infinity. and then it's decreasing between those two from 2 to 7 is decreasing. Alrighty, and there it is, everybody. Nice work on 1.3, and we'll see you next lesson.